So the first question is, how many revolutions are needed to rotate by 400 radians? Well, what do we know? For one revolution is how many radians? 2 pi, right? So the angle that's swept out in one revolution is 2 pi. So if we know that there's 400 radians, 400 radians, okay, and one revolution is 2 pi radians, right, for one revolution. So how are we going to figure out how many revolutions? 400 divided by 2 pi, right? Okay, what's the answer?
63.
Okay. Now, just want to point out a common calculator mistake that people make all the time is they do this: 400 divided by 2 pi. Okay. And when you do that, the way your calculator interprets this is 400 divided by 2 times pi. Okay, times pi. So you do have to parenthesize this if you're going to divide it, or you could divide it twice, would also work. Okay, how long would that take at the slow speed? So we want to know the slow speed, right? Well, the slow speed is 50. Let's just think about it conceptually a little bit. The slow speed is 50 RPMs. So 1 minute, it's going to go in 50 revolutions, right? And this is 63 revolutions. So approximately how long is it going to take?
A little more than minutes.
A little bit more than 1 minute, right? Because it's 50 revolutions in a minute. And if it's 63 revolutions, it's going to be a little bit more than 1 minute, right? Well, how would we actually figure that out? Okay, well, we would say 63.7 revolutions, right? And I'll do it like this: 50 revs per 1 minute. Okay, so we're going to get a little bit more than 1 minute, right? 1 point how many? 27 minutes. Okay, now the question didn't really specify whether it should be minutes or seconds. In general, if they don't say that, what should we put it in? Seconds, yeah. So I'm going to go ahead and do that. Multiply by 60 seconds per minute. And you get about 70 something. Okay, letter C. What is the angular velocity at the slow speed? So this is a very common conversion that you're going to make over and over again. So you should get good at it. So 50 revs per minute. What's the conversion? Well, let's change it to seconds first. How do we change it to seconds? 1 minute is 60 seconds. And how do we change that to radians? 1 revolution is how many radians? 2 pi radians. Okay? What are we getting? 5 point what? Is that being confirmed? Okay, by the way, if you want to see kind of a shortcut for this conversion, it is a common conversion. If you just combine this all at once, right, what can we just multiply by? 2 pi over 60. Yeah, 2 pi over 60, or even pi over 30 if you want to do it like that. But that's kind of the quicker conversion. We are going to do that conversion a lot. Revolutions, RPMs to radians per second. Okay, letter D. What is the angular acceleration? All right, how do we find angular acceleration? Alpha equals delta omega over t. Okay, or we could also write this as omega final minus omega initial over t. Right? Now we just found omega initial. What else do we need? Omega final. So you do have to find omega final. Now you could do it again, the conversion we talked about. You could even do it faster than that. Because look over here. We started at 50, we ended at 300. How much faster is that? No. 6 times faster, right? We went from 50 to 300. How much faster is that? 6 times faster. So what's the quick conversion? Multiply your initial times 6, right? So this should be 5.24 radians per second. That was our initial. If we multiply by 6, that's going to give us our omega final, which looks like it's about 30 something.
31.4.
Okay, now if you don't like those quick and easy things, you could do it the long way and you'll get the same answer, right? You always get the same answer. All right, how do we find this? Let's find alpha. So our omega final was 31.4. Our omega initial was 5.24. And our time was, I want to say 5, is that right?
Yeah.
And we get about 5.
5.2.
What's the units for this?
Second.
Radians per second squared, not meters per second squared, radians per second squared. Okay. By the way, I'm going to do something here just as a preview for today. Let's just look at this equation right here. Okay, alpha equals this. I'm going to rearrange this. Multiply by t, add omega naught, see what we get. If I do the algebra here, I'm going to get omega final equals omega initial plus alpha t. Does that look familiar? Looks like kinematics equation number 1, right? Except instead of omega, what is it? Velocity, and instead of alpha acceleration, it's alpha, right? So this is very similar,
Which one's omega?
essentially identical.
Is omega the...
Omega is the angular velocity. Alpha is angular acceleration. Okay, let's do letter E. A, B, C, D, E. I think I'm just going to fold this over. Okay, if the car continues at the top speed, how far will the car travel in 1 hour? 1 hour. So there's a lot of different ways you can solve this. Let's think about this kind of conceptually. If you have your wheel here, right, and if I move the wheel 1 full revolution, like this, how far is that wheel going to travel? The circumference, yeah. So this, in 1 revolution, the wheel, and if this was attached to a bike or a car, it would travel 1 full circumference, right? So if we went 1 revolution, we would go 1 circumference. Well, what if we went 300 revolutions? How far would it go? 300 circumferi. Okay, so we would go 300 of those, right? So let's figure that out. So we're going 300 RPMs, so that's 300 revs per minute. Actually, I asked for 1 hour, right? So let's figure out how many it's going to be in an hour. So 60 minutes, right, in 1 hour equals 18,000 revs in 1 hour. Okay, and then how are we going to find that total distance, therefore? Multiply by the circumference. So 18,000 times 2 pi 0.6 equals a lot.
67,850.
And that's going to be meters, right? So about 60, almost 68,000 meters. Okay. How are we going to find the velocity? So yeah, so this just told me that I traveled almost 68,000 meters in how long? 1 hour, right? We just traveled that many, so that actually is a speed, right? Meters per hour. Now that's not the common speed we're going to want to use. What are we going to convert that into? Well, you could do kilometers per hour, but what's the standard unit? Meters per second, right? So that's meters per hour. So 1 hour is if you don't know that straight conversion, just do 60 and 60, right? 60 minutes, 60 seconds. All right, so what's our meter per second speed? 10.52? 18.8, is that what you said? 8.5. Okay,